the time you spend with your internet takes time. A lot of use Excel extensively as the paragraph. That's considered asexual concept. The graph has this idea of to use in Excel, which is what we work, which is how to do it at home. And that way the idea is that it's always the barrier to learning. It's much more the learning curve. They can look at how to consume Excel already. So how to use Excel, it's not as difficult as being practiced. Their goal of this that program is to make it fun because you want to make it for you, but move out and the other cities that I have on their channel for the time. So they have a video you're interested in about generating because you have an entire skill set to edit this year's news because it's what I have. On the trainer, most of your experience is in data set, so it's going to be a plus. Actually, you have a 6-foot programming background for other features. For example,
world, and why connect the open source ideas and the scientific world? And there's kind of a few different lines of motivation for me. The first one, I'm a geek, I'm a scientist, was technical. I wanted better tools. We have to kind of wind the clock back to 2001. I was a graduate student in physics, doing a PhD, studying the behavior and interaction of the smallest constituents of matter, quarks and gluons. These are the teeny little bits that go inside of protons and neutrons. And in practice, what that amounts to is basically babysitting large supercomputer simulations with what at the time for me was a rickety Rube Goldberg machine of many, many programming languages and tools that kind of strung together simulations and analyzed their outputs, etc., in a variety of programming languages, including a few proprietary ones. And at some point, my office mate said, "Hey, you should learn about this Python language. It's really cool. It's very nice." And I really got sucked into it. As I said, I'm kind of a geek, and I love programming. And I thought, maybe I can replace part or all, if not all, most of this rickety tower with a much simpler and more elegant solution based on Python. Saying that in 2001 sounded crazy, and people told me it was crazy. But I thought, well, what better way to not finish a dissertation than to get sucked into programming? But there was a technical argument actually to be made that they were a language that had very good capabilities for interactive workflow, and this was really important. I was not into the business of building software engineering, but thinking about science, about data, and that workflow of exploring a problem, using the computer to reason about a problem is something that probably many of you do. You run some code, you look at some visualizations, you look at some data, you interact with the system, and Python had good machinery for that, but it could be made better. And so I started building something that I called at the time IPython, which was basically a 2-little hack, a few hundred lines of code, but I also obviously was reading a lot about this. I was trying to soak up as much about the language as I could, and I found this blog post from O'Reilly incident 15 years ago, and the blog post is still up. I actually took those screenshots 2 days ago that talked about interactivity in Python. And it listed 2 other projects, one created by a graduate student called Nathan Gray at Caltech, and one by an oceanographer in Germany, Janko Hauser, which were both, so they had both built tools for interactive usage of Python. I emailed them both, and I said, hey, we should join forces, and maybe we can build something together that will be a really neat environment for interactive work in science. And they both very kindly replied with more or less the same email, and they said, I'm too busy right now, I have other things going on, please run with it. So I did. I kind of disappeared from my advisor's radar for a few weeks. He probably thought I had fallen off the face of the earth. And a few weeks later, after a long 6-week coding binge, I announced on the Python mailing list the first public version of IPython, and I want to emphasize that from the very beginning, this was a collaboration. This was possible because other people generously gave me their code and encouraged me to kind of work with what they had built. Now, the next layer of motivation is actually an ethical one, which for me matters a lot. It's about access. It's about the possibility of collaboration. I was born and raised in Colombia, in Medellin, a city which is unfortunately infamous for its history of drug problems back in the 80s and 90s. That's when I grew up. It's also an amazing city with beautiful architecture, with great innovations in public transport and public engagement. But importantly for me, I realized that if I continued using proprietary expensive tools for my work in the United States, which I did have access to, I was doing a PhD in Colorado, in Boulder, I couldn't collaborate easily with someone like my former undergraduate advisor, who probably would have, excuse me, this is called who would probably have difficulties accessing this expensive proprietary software with the research budgets that we had in Colombia. And the idea of building research with open tools for this reason was validated when in 2010 I had a chance to attend the Scientific Python 2010 conference in India, and we ran a workshop to include students from underprivileged colleges in rural India to participate in scientific research, to learn how to use these tools and to contribute to open source. This was an amazing and beautiful experience for me, which would not be possible if we had to get expensive proprietary licenses for the packages for them. The next layer of motivation is actually a scientific one, an epistemological one, if you will, which is that science, the business of science, is understanding how the world works, is understanding nature. And we can't, in good conscience, say that we are going to understand nature with tools which themselves were not allowed to open and understand. If science is about opening up the black box of nature, we shouldn't be doing that with things which themselves we are not legally allowed to understand. And I think this is captured well by Feynman's very famous and often repeated quote. So these 3 layers of motivation were kind of what drove me in. But in the long run, what actually happened was the value of the community. In 2003, the sci-fi world was kind of beginning to take shape, and I was invited to one of the early sci-fi conferences by Eric Jones, the co-founder of NPOT, and he basically offered to cover my expenses to come to this conference at Caltech. For me, this was kind of a life-changing experience because I didn't have any resources. I was a poor postdoc, and Eric very generously invited me, and I realized there were other people who cared about these same things, who didn't care so much about competing with each other and jockeying for position in academia for papers, but they just wanted to get together and build an open world together. That was a conference where I met John Hunter, who became a lifelong friend, who was the creator of Matplotlib. Very sadly, he passed away in 2012. But not only did we become incredibly close friends, we also started a very tight partnership between the Matplotlib team and the IPython team to make these 2 tools work together better so that you could work interactively and visualize your data better. And over time, obviously, this continued into partnerships like what we have with Brian Granger, my co-PI and co-lead in the project, and his, at the time, undergraduate student, Reagan Kelly. Both of you in the community probably know of their innumerable list of contributions to the project. This is a partnership that continues to this day, and it's absolutely amazing to have the chance to work with people like them. But it's not just the two of them. It's actually an entire team. This is a picture of our last all-hands team meeting a few months ago in Berkeley, where we have, these are the people who deserve all the credit for all the tools that we use. It's not one or two people. It's an entire team to make this possible, in addition to the hundreds of contributors who in the open source community have brought their code to us. And this idea has probably been best captured by Brett Cannon's quote, which has now made it all the way into t-shirts. I came for the language, but I stayed for the community. And we'll have a chance to see Brett speaking tomorrow as one of our keynote speakers. Now, switching gears into what it is that we're building, if I have to kind of try to capture in a sentence, we're trying to build human-centered tools for interactive computation in science, where the human at the helm is what matters, whether we're working in a variety of tools that are anonymous. It's all about building a machine to interface between computational resources, data, whether it's a supercomputer, a laptop, the cloud, and your thinking, your reasoning, your insights, your ideas about a problem. Because this is the one part that isn't getting any bigger and is not scaling with the internet. And so whether you're working at the terminal in the test environment, just pulling up a few plots, or building a sophisticated notebook with graphical controls that you're sharing in your organization, that you're deploying to colleagues or to customers, at the end of the day, it is about giving you the tools to help you think and reason through. And what began to happen over time was that we realized that those ideas of reasoning, exploring computation interactively, weren't really connected to the Python programming language. What mattered was really that aspect of exploration that could be done in any of a variety of programming languages. You could do that in Julia, for those of you who like Julia. We had a poster yesterday from the Julia community here. You could do it in R. We had a fantastic tutorial yesterday from the R community, or in any of many more. And so this is how Python kind of evolved into Project Jupyter, was basically abstracting those ideas of interaction to become a platform for this notion of human-driven computation, exploration, and communication in whatever programming language suits the needs of a problem better. And so if we look a little bit at what it is that we're trying to build, there's kind of a layering of the system, and I think it's useful to think about these layers. At the lowest level, we have basically what we're trying to build as open standards. There's a messaging specification, there's a protocol, there's a format for the notebook files. All of these things are very carefully specified. And they're basically standards. You can think of them as informal standards. On top of those, we have libraries. We have open source libraries that implement and manipulate these standards, that give you the Lego building blocks to assemble things based on those ideas and those standards. On top of those, we have applications like the Jupyter Notebook, the next generation interface that we're very excited about, Jupyter Lab, tools like Jupyter Hub, or even the classic Python console. These are user-facing applications that are built on these libraries that basically surface these standards for you. And then we build services that propagate these out to make them usable to the community, web services that would expose these things to the wider world. All of this is in support of an open ecosystem. We want you to come up with new ideas, new tools, new implementations that use at any of these layers. But I do want to make the point that that lowest layer of protocols and formats is not the place where forking and needless replication should happen. This is the place where we try to have the standards that serve us all. It's also open, which means if there are problems there, come to us, work with us, let's improve it together. But it's important that we kind of come to some of the foundational agreement on key parts of the infrastructure so that the rest of the ecosystem can continue to grow and collaborate and interoperate. And in the leaves of the tree, it's perfectly fine to have competition and evolution and creativity and ideas, but I think it's important that we understand what pieces are the pieces that we all benefit from a technical perspective. Now, where are we headed next? Where are we going? Well, hopefully you're going to see a lot of that in this conference. I'm not even going to have time to go into any details because the whole point is that you're going to see many fantastic presentations, some from our team, some that we will see from others and members of the community of things that are happening. We have exciting developments like Jupyter Lab, which is effectively the next generation interface based on everything we've learned about the usage of the notebook and the Jupyter tools in the last few years, what's happening with Jupyter Hub, the Binder project, and Vidime and many, many other things, so I won't go into the details of that. I just want to flag a couple of things that I'm kind of personally very excited about. This is a slide that a few years ago I used to have maybe one, I think I only had one book, the one on the top left, where I would say, look, it's possible to buy a book, a hardcover book, that you can also effectively execute. So books are becoming live computational entities. You can buy this thing from Amazon, but you can also download it from Git and execute it. And now that slide has 8 books and continues to grow. O'Reilly has actually been kind of a leader in making this possible and embracing these ideas. It's no coincidence that we're here. And but I'm very excited of sort of seeing the book, which we all love, kind of evolve in this direction, and for Jupyter to be able to kind of power and provide the tools for this based on completely open standards and tools. And books are connected to education. I'm at a university, and this is something that we're going to have an entire talk about this, so I don't want to completely steal their thunder, but I want to sort of flash something which is really exciting that is happening at UC Berkeley, which is the teaching of data science ideas, computational and inferential thinking ideas to the entire university. Berkeley is kind of really, really embracing this notion that data science is a foundational skill for citizens of the modern world, and there's a course called Foundations of Data Science, which you can go to. It's an open book, but if you click on the chapters of the book, you get to pages like this, which are effectively notebooks where there's blue buttons that say Interact, and when students click on those buttons, they come to a Jupyter Hub hosted version of the book, the libraries, the data, and the whole environment. This is all based on work that the team built and a prototype that Jess Hamrick ran on campus a few years ago, and now there's an entire team. All of the names in red are actually here at the conference. They are the ones who are basically building and running this. And I have this really amazing and exciting picture from yesterday. This was the first lecture. The semester began yesterday at Berkeley, and this was the first class of this semester's iteration of the course. This is the fastest growing course in the history of UC Berkeley. Now, this is Wheeler Hall. It's the largest hall at UC Berkeley. 1,200 students. You can see along the sides people sitting in the floor. I don't know what the fire marshals have to say about that, but the point is this thing is exploding, and the idea, there's 60 majors represented here. This is not a course for computer scientists or for statisticians or for physicists or mathematicians. It's for everyone. And on top of it is a collection of courses that then bring data science ideas into all of the domain disciplines. This is very exciting, and I encourage you to meet the team who made all this possible to work, many of whom are here. Now, with all of this being exciting and things that we love and that I think are providing great value in a variety of ways to society, how do we keep this little engine going? I'm worried a lot about sustainability. It's something that kind of really keeps me up at night. How do we make this possible as something that will continue to grow and be healthy? And I was reading about this, and I stumbled on this post from Tim O'Reilly, who just came up with a book. I know this is a topic that he thinks a lot about, and there was this quote in his blog post about his new book that I think really captured the essence of the problem very well. In this case, he's talking about industry platforms, and he's asking the question of how do they build healthy ecosystems by balancing the value that they capture for their platform and what they return to the community. And from our perspective, the question is that we're kind of in the flip side of that. We would like to think we provide a lot of value, but we capture very little of it in the sense that we don't retain everything we do is open, everything we do is free, everything we do, and we like that. We think it's important to provide that to the community, but how do we balance that? Industry platforms are being built atop Jupyter machinery, and this is something that we are excited about. We have phenomenal collaborations with all the teams here, Continuum Analytics, with IBM, with Microsoft, with Google. They've all contributed to the project in very, very significant ways, so this is a very, very good thing. But the long-term question of what is going to be the interplay between the open community and the existence of these very large-scale industry platforms, I don't think it's a completely answered question. We'll have a fantastic keynote tomorrow from Nadia Agbal that I'm very much looking forward to. She has done enormous research exactly on this problem, and this is part of the reason why we wanted to have Nadia here. Now, I do want to flag that in the community we've built an organization to worry about these problems. It's called NumFocus. We have members of the board of NumFocus here. We have a booth outside together with Project Jupyter. NumFocus is a nonprofit organization precisely whose mission is to steward not Jupyter, but an entire collection. It's not Jupyter specific. It's a collection of projects in the open science ecosystem, and to find ways for these projects to be healthy, to grow, to interface with academic research, to interface with government, to interface with industry, and evolve sort of the conversation around health and sustainability of these communities. Unfocus is going to be running a summit in the fall focused on the problem of sustainability, and this is a problem that I think we all need to